In this problem, everything we know about the function is contained in the graph which I've reproduced here. That in addition to the fact that we know one point, f of 1 equals 3. So it's vital that we notice that the graph that they've given us is not the graph of f, but rather the graph of f prime. And that means that questions that have to do with the second derivative of f are really questions that can be interpreted about the slope of this graph. Questions that have to do with f prime are about the height of this graph. And questions that have to do directly with f are going to involve some sort of use of signed area of this graph. The specific questions that they're asking us have to do with local maxima, points of inflection, absolute minima, and then intervals where the graph is concave up and has positive slope at the same time. So this is information that's going to be useful to us in handling those four parts of the problem. Let's go ahead and just get started with part A. We're being asked to find all the local or relative maxima. Now we know that maxima occur where f prime changes sign, but f prime is just the height. Okay. So let's start off there. Local maxima and again, local and relative are identical, interchangeable words in this context. Local maxima occur where f prime changes sign. Now maxima is when f prime changes sign, if you think about a peak, from positive to negative slope as we go from left to right. From plus to minus as we go from left to right. And where does that occur? Again, we're talking about f prime. We're talking about the height. Where does the height go from plus to minus? Well, the height goes from plus to minus here at -3. The height goes from plus to minus here at 4. That's it. Now, if we want to consider the endpoints, and the reason I say if, let's pause on that for a second. Okay. There is actually a debate within the calculus community about whether endpoints when we're talking about closed intervals, whether endpoints should be included in the discussion of relative min and max. Just to be on the safe side, I'm going to work under the assumption that we do need to consider them. And so if we were to consider endpoints, okay, first thing to note is that at -5, f prime is at 0 but immediately goes positive as we go from left to right. So that means points that are immediately to the right of -5 are going to have a higher value than the point at -5. And so -5 is ruled out as a potential, it's ruled out as a local maxima because there are nearby points that are higher than it. Okay. So I'm going to just note that we just say at x equals -5, is ruled out because f prime just to the right of -5 is positive. Similarly, at the other end, at 5, and x equals 5, okay, That's also going to be ruled out because here the f prime value is negative, right at 5 as well as immediately to the left. And so that means that values just to the left of 5 are higher, have a larger f value than the value at 5. So it can't be a local maximum. Okay. So we'll say that as well. X equals 5 is ruled out. Because f prime of 5 is negative. So negative 3 and 4 are our options. Part B just asks us to find a point of inflection. Okay? And a point of inflection means that f double prime changes sign. Well, remember, f double prime is represented on this graph by the slope. So we're asking, where does the slope change sign? Let's just write a couple of words out. Okay? Points of inflection occur where f double prime changes sign. And where does that happen? Okay. Again, f double prime changing sign is equivalent to the slope on this graph changing sign. Well, here we have positive slope and now negative slope. So negative 4 is one place where f double prime changes sign. We've got negative slope here all the way down to negative 1. And at that point, the slope becomes positive. So here's another place. We've got positive slope here all the way through 2. And then it becomes negative. So here's one final place. From 2 on, the slope remains constant. So there are no further points of inflection. So let's just write this out. At x equals negative 4, negative 1, and 2. Part C wants to know where the graph is both the graph of f, again, not the graph shown, where f is both concave up and has positive slope. So concave up is the same as f double prime being greater than 0 on the graph at right. That is slope greater than 0, which occurs over what intervals? Well, where's the slope greater than 0? Negative 5 to negative 4, and negative 1 to 2. But they also want to see positive slope for the f function. That means f prime positive, which means the height of the graph shown, the height just being positive. That's from negative 5 to negative 3 and from 1 to 4. So let's write that. Positive slope is the same as f prime greater than 0. And in this graph, I'll just say on the graph, at right, where height is positive, and that occurs at let's let's see, -5 to 3. And 1 to 4. Okay, so the intersection of these intervals is where both occur. Which is x -5 to 4 and x 1 to 2. So D. Now we're finding absolute minima. Before we found local maxima, now we're finding absolute minima. So minima occur where, let's start with all the local minima. That's when f prime changes sign from negative to positive. Let's be sure to mention as we go left to right. Okay. When f prime changes sign from negative to positive, so when does f prime, namely the height, change from being negative to positive? Only right here at 1. At x equals 1. We also consider the endpoints. In fact, the very arguments that we used to show why the endpoints were not local maxima qualifies them for being local minima. So we have 3 local minima to check, and we're trying to find the one of those 3 or more that has the highest height. So let's look at the 3 points that we have to consider. We've got to think about x as well as f of x. We need to consider 1, we need to consider 5, and we need to consider -5. 1 is the easiest. The height is given to us. F of 1 equals 3. 5, we had to add the signed area in. So as we move from left to right, the signed area is going to be 3 plus, again, this is the fundamental theorem. We'll add in the signed area from 1 to 4. That's 1/2 of 3 times 2. And then we have to subtract off signed area as we go from left to right, because this has a negative signed area. That's 1/2 of 1 times -1. So that's -1/2. I suppose, strictly speaking, we're adding a negative signed area, plus 1/2 of 1 times -1. But the result, 5.5, I think, is clearly greater than 3. So our candidate for absolute minimum is still 3. Now let's consider -5. Here, we're again using the fundamental theorem, adding signed areas from starting at the location of known value, and then going, in this case, from right to left, the area of the derivative, signed area of the derivative. So from 1 to -3, we are adding, okay, we have a negative signed area, but because we're going from right to left, we're going to add it in positively. So what is the signed area? Well, this is half of a circle. The radius, you can see, is 2. It goes from -1 to 1, or -1 to -3. Area of a circle, pi r squared. When the radius is 2, the area is 4 pi. We've got half a circle, so it's 2 pi. Again, we were adding negative. This is a negative signed area, but we're moving from right to left. So we're actually going to add in the 2 pi. Just the opposite thing happens here as we go from -3 to -5. Namely, it's half of a circle. It's positive signed area, but we're moving from right to left. So we're going to add it in. We're going to subtract it. And I think you can quickly see that the area of this half circle is 1/4 the area of the previous one. So we're going to subtract off pi over 2. Regardless, we're getting a number that's bigger than 3. And so even though we've tried 3 candidates to find that absolute minimum, it's the first one that proves to be the absolute minimum. So let's just conclude by writing explicitly that the absolute minima, absolute again being interchangeable with global, the absolute minimum is 3. Notice they didn't ask us where it occurred. We needed to find that out along the way, but what they wanted to know was the height. And recall, we could have found this height in more than one location. Okay. It is, again, the height that they're focused on when they ask what the absolute minimum or maximum is.